One last thing before leaving the empirical rule. Some people prefer to quote the empirical rule as follows. Create a new variable by looking at your old variable, subtract its mean, and divide by its standard deviation. Call that t. And this is called a standardized version of the variable. So subtract the mean and divide by the standard deviation. Then the empirical rule says that we can compare this quantity t to an absolute number. Instead of saying mean plus 1 minus 1 standard deviation, then these are the empirical rules. The mean plus or minus 1 standard deviation turns out to be just 1. So in other words, this variable here, the standardized variable, has got standard deviation of 1. It's got a mean of 0 and standard deviation of 1. So this is maybe a simpler way to remember this, that mean plus or minus 2 standard deviations now becomes just mean t less than or equal to 2, and mean plus or minus 3 standard deviations becomes t less than or equal to 3. So this is an alternative way of stating the empirical rule. Okay, just compare it to t and what are the values that t takes. So t has to be less than or equal to 1, 2, or 3. And here we go. With our diastolic blood pressure, the mean was 84, standard deviation was 12, and so there's our t value. And then mean plus or minus standard deviations is between minus 1 and 1, mean plus 2 standard deviations is minus 2 and 2, mean plus or minus 3 standard deviations is minus 3, 3. So in summary, the standard deviation together with the mean allows us to make summary statements about the distribution of our data. Do not forget the assumptions. The assumptions are of symmetry and of unimodality. Okay. Now, there are other measures of dispersion, such as the range and the interquartile range. Remember in the box plot, when we had the box plot like this, this is the interquartile range, the distance between the lower quartile and the upper quartile. And the MAD, what I was talking about, the mean absolute deviation. And these are also sometimes used. But by far the most ubiquitous is the standard deviation. And you see the value of the standard deviation.